Hello everyone, welcome to today's class. Today we are looking at AS Pure Mathematics 1, paper 970/11 for October, November 2022. And this is for part 1, questions 1 to 6. Question 1 is coming from quadratic equations. They're saying solve this equation here. So the first thing we are going to do is to cross multiply, not so. So we shall have 3x, then plus 2, then times this x minus 1, then we equate to 2. Then we open the brackets. So 3x times this x here, you get 3x squared. And then 3x times negative 1, you get negative 3x. And then you have 2 times x, that one will give us 2x. And then 2 times negative 1, you get negative 2. Then bring this one this side to be a minus 2, then we equate to 0. So meaning the quadratic that comes from here is 3x squared, then minus x, because when you simplify here, you get that. Then minus 2, that is minus 4, which is equal to 0. We can put this in the calculator to simplify the work. We shall go to mod, then equation is 5, and then quadratic is 3. Then we shall have 3 here, then negative 1, and then negative 4. Then that is 4 over 3, and then negative 1. So I will have x here equal to 4 over 3, and then the other one, x is equal to negative 1. But if I do like this and just go, that means I'm going to lose the answer. I'm going to lose one of the marks. Why? You need to show the examiner the attempt to solve this quadratic equation. So give us the factors from which these roots come. So how do you do that? Cross multiply here. You will get a 3x, which is equal to 4. Then bring the 4. So it will be minus 4. That is the factor which gives us this. Then bring this one this side. It will be x, then plus 1, which is equal to 0. So as simple as that. So this will be the answer. And also this one here. Question 2. The equation of a curve is such that dy dx is equal to this. It is given that the curve passes through the point, this one here, part A. Find the equation of the tangent to this curve. Okay, so the equation of the tangent, you know that gradient of the tangent is always equal to dy dx. Okay, so if you have a curve here, and then you also have a tangent there, this tangent is having at the point of intersection, they have the same gradient with the curve. You see that? Because the gradient between any 2 points on the straight line is always constant. And for the curve, it is always changing. Okay, it is always different at those different points. So that's why when it comes to the curve, they have to give you the reference point on that curve. You see that? All right. So that is why even here they have said at point what? Point P. Now at P, which is 6, 4, what is dy dx? So dy dx is going to be 12, then out of, this will be a half, x is 6, then minus 1, and then power 4. So this will be 12, then out of, a half of 6 is 3 minus 1, that is a 2, then 2 power 4, that is a 16. By 4, you get 3. By 4, you get 4. So it is 3 over 4. Now using y minus y1, which is equal to m into x minus x1, y minus our y1 is this 4 here, and then m is 3 over 4, then x minus 6. Remember, to find the equation of a straight line, you need to get two things. Number one, the gradient, and at least one point through which a line passes to help you find the y-intercept. Okay, so y is going to be equal to 3 over 4, then x minus, when I get this times this, I will have by 2, 2, by 2 here, 3, then 3 times 3, that will be a 9, then over 2, right? So I'll have 9 over 2 here. But then when this one crosses, it will be a plus 4. So meaning the equation of the tangent is going to be y, which is equal to 3 over 4 of x, then 2 times 4, you get 8. 8 minus 9, you get -1. So that will be -1 over 2. That becomes the equation of the tangent. And then part B, find the equation of the curve. So they differentiated, okay, to get this. This is the gradient function. So that means to get the equation of the curve, they differentiated y. So to undo this one, I have to integrate, right? So meaning y here is going to be equal to the integral of 12, then into, what do we have here? A half of x minus 1, a half of x minus 1, then to the power of -4 with respect to x. Now, this one will give us, put the 12 outside here. Now we are integrating this one. Remember, when you are integrating, you take away the integral sign. So I'll have something like this. And then what are we going to have here? We're going to have a half of x, then -1. Increase the power by 1, you'll get a -3, okay? Divide by the new power, which is -3. Then times the derivative of what is inside here, which is a half. Then we shall put an arbitrary constant here, because we don't know the constant that disappeared when we differentiated. And we know that when you differentiate a constant, you get a 0, okay? Now this one simplified, what is it going to give us? This 2 will somersault and goes up to there. So it will multiply with the 12, that will be 24. Now 24 divided by -3 is that -8. So we shall have -8, then out of, I'll take this one down, because using the rules of indices, this is the same as a half of x, then -1, then the power becomes a positive here, okay? Then plus c. Now, if a point lies on the curve, that means its coordinates must satisfy the equation of the curve. So we have point P. Is it 6, 4? Yes, it is 6, 4. So that means the y coordinate is a 4, and then the x coordinate is a 6. So a half here times 6, that one will give us a 3 minus 1. What do you get? You get a 2. Then 2 cubed, that will be 8. Okay? So we have 4. Then here, this is -8 divided by 8, that will be a -1. So I will say plus 1, that one will be equal to c. That means our c is going to be what? 5. So meaning that the equation of the curve y is going to be equal to -8 out of a half of x minus 1 brackets cubed, then plus 5. So I substitute the coordinates of P here to help me get the constant here. So that is that. Question 3. A curve has this equation where x is greater than 0, it's a positive, and a is a constant. The curve has a stationary point at P, which has the x coordinate 9. Find the y coordinate of P. So what we are going to do is to differentiate and then equate to 0, okay? So if y is equal to a, then x power half minus 2x, that means dy dx is going to be, remember we drop the power and then we reduce it by 1, so this will be negative a half, then minus, of course here we shall get a 2, okay? And we know that for stationary points, what do you know? Dy dx is equal to what? 0. So if dy dx is equal to 0, we shall now substitute. We are going to get this one and we equate it to 0. But the x coordinate, when we equate this one to 0, we are supposed to get the x coordinate. But the x coordinate is given as a what? As a 9. So for then x is equal to 9, we substitute a half of a, then 9 power negative a half minus 2 will be equal to what? To 0. So this one is going to be a, then out of 2 here, then times the square root of 9 is a 3. Okay, then this one is equal to 2. Then when we cross multiply, then our a becomes 2 times the 6, that is a 12. After getting that, then what is the y coordinate? So therefore y is going to be a, which is 12, then x, remember, is 9, so the square root of 9, then minus 2 times x, which is a 9. So this one will be 3 times 12, that will be 36, then 36 minus 18, that will be 18, not so. So y then becomes 18, as simple as that. Question 4. The coefficient of x squared in this expansion here is 70. Find the possible values of constant p. So I will first consider this one here. Remember, we are going to use the binomial expansion, which states that if you have a plus b then to the power of n being a positive integer for pure mathematics 1, for pure mathematics 3, this n can be a negative or a proper fraction. Even if it is not a proper fraction, for such series, they don't end. We call them infinite series. But for the positive integer, these ones end. So we have n, then combination 0. We have a to the power of n, then b to the power of 0. So the power of the b is the one that goes into the combination here. Okay, then plus, now we have n combination 1, then a. As a drops the power, then b picks that power. You see that? N combination 2, then a power n minus 2, and then b power 2, and then you continue like that until you get b to the power of n. Now, if we have 1 plus 2 over p of x, and this is to the power of 5, okay, we want the coefficient of x squared, so we want here the term in x what squared. The powers here are going to move like this. The first term has this power of 5, just like you have n here, then goes on to this, you see. So we have 5, then 4, 3, 2, 1, 0, and then the second one begins from 0, then 1, you see. So we have 0, 1, 2, 3, 4, and then 5. So when you look at these pairs, they all add up to the n, which is given here, the 5. Okay, all right. Now, term in x squared, this one is going to be, first of all, you have 5, then combination something, then we have 1 here, and then we also have 2 over p of x. So the sign that is here, please, you take it together with this term here. If we have a minus, you will take it with it. If you don't, then you get wrong things. So x has to end in a square. That means I will put a 2 here, then this one will be a 3 here. Okay, and then this power that is here, I put it here, just like that. 5 combination 2 is 5 times 4, 20, divide by 2, that will be 10. Then 1 square, 1 cubed is of course 1. And then what else do we have here? This is 2 squared, that will be a 4. 4 here, then out of p squared, and then that is x squared. Okay, then we also have this other one here, 1 plus, then p x power 6. This one is, the powers are going to move like how is 6, then 5, 4, 3, 2, 1, 0. Then we have 0, 1, 2, 3, 4, 5, and 6. We are not supposed to expand each and everything here because this one has 7 terms, right? We only need the term in x squared. You get that? So term in x squared here, this one will be, we are going to look at 6 here, then combination something, then the terms we are having are 1 and then px. So for this one to end in a square of the x, then we have to choose from here. Okay, so for this other one here, we chose from here. So if I put 2 here, x will end in x squared, you see. Then that means this one will be a 4, and the power here is the one that goes in here in the combination. So we shall have 2. Then 6 combination 2 is 6 times 5, that is 30. Then divide by 2, that will be 15. Then 15 times 1 power 4, that will be a 1, and then p squared. Okay, then x squared. So this is the coefficient of x squared here. This is the coefficient of x squared here. So since we are having these two series being added, okay, that means the term in x squared for both of them will be this, then plus this one here. So what I would just do is to get the 40 over p squared, the coefficient of x squared here, then I add it to this one here, which is 15 p squared, and then I equate to 70. Then from here, I'll eliminate the denominator here, so I'll multiply all through by p squared. When I do so here, I'll have a 40, then here I'll have 15p, then to the power of 4, and then this one will be 70p squared. You see? Then we can have, this is a quadratic in p squared. I can divide all through by 5. That means we can have 3, then p squared, okay? That is the p power 4. Then, when you divide this one by 5, what do you get? Don't you get a 14? But bring it this side, so that will be minus 14, then p squared, and then 40 divided by 5 is 8, so plus 8, which is equal to 0. I said this is a quadratic equation in p squared. So let's check whether this one is factorizable. We shall go to mod, then equation is 5, and then quadratic is 3. Then we shall have 3, then minus 14, then 8, and then we get a 4, and then 2 over 3. So I will say p is equal to 2 over 3. By the way, it is p squared because it is a quadratic in what? In p squared. And then the other one is equal to what? To 4. Now, you have to show the examiner the attempt to solve the quadratic equation like I said before. So give us the factor from which this comes and also this one. So when we cross multiply here, we shall get 3p squared, then is equal to 2, then bring the 2 here, which will be a minus 2 here. And then this one, bring it here, you have p squared minus 4, which is equal to 0. You see that? Now, when we check up here, they are saying find the possible values of the constant p. So the possible values from here, p can be equal to the square root of this, but it's going to be plus or minus the square root of 2 out of 3. Then also p can be plus or minus the square root of 4, that is a 2. So we can have these two or these two. Then question 5, this one is coming from circular measure. The diagram shows a sector OAB of a circle with center O. The length of the arc AB is 8 centimeters. It is given that the perimeter of the sector is 20 centimeters. Then part A, find the perimeter of the shaded region. Perimeter of the shaded region, I will need this length AB, and I will also need this arc, okay? So if they are saying that the perimeter of the sector is 20, so we begin from there, perimeter, or I can start from this one here. The length of the arc is this. You know that arc length is equal to theta. If it is in degrees, then it has to be out of 360 degrees because angles at a point add up to 360 degrees. So there is an angle there, okay? So I'll put actually theta here. Then times, because this arc is part of the circumference of the circle, then I will multiply by 2 pi r, which is the expression for the circumference of the circle. But if theta is in radians, that one is going to be theta, then out of this 360 is the same as 2 pi, then times the 2 pi r here. So you can see that the 2 pi cancels, and then we shall get r theta. Then area of the sector, because these are the most important formulae that we can have here. So area of sector A sector is a portion of the circle, so it is theta out of 360 degrees, then times pi r squared. Okay, it's a portion of the circle, so the circle is all of that, but then it has taken only this portion out of the whole circle, you see. So meaning, if theta is in radians and this 360 is also in radians, that is 2 pi, then times pi, then r squared. So pi can go, and then we remain with a half, then r squared theta. Okay, now arc length here, r theta, is going to be equal to this 8 centimeters. Okay, 8. So we have that as equation 1. Then we go to the perimeter. Okay, perimeter. So let me put this one down here, and I say arc AB is equal to 8 centimeters. Then we go to the perimeter. Perimeter of shaded segment. Perimeter of the sector, pardon me here. Perimeter of sector. Sector, which one? OAB. This one is equal to, you will have R. This one is going to be R. This one is R. Okay, so R, then plus R, then plus this one here, the arc length there. So plus R theta. Okay, arc length of AB. Now, what do we have here? This one, remember, it is equal to 20, not so? Now, R theta, we have it as 8. So 2R here, then plus 8 will be equal to 20. So when you take this one this side, 2R will be equal to 20 minus 8, isn't that 12? So that means R is going to be equal to 6 what? Centimeters. If R is equal to 6, then this simply implies that our theta then shall be equal to 8 over 6. We divide through using this one here. So our theta will be equal to 4 out of 3. And this one is in radians. Okay, that is that. Theta has to be in radians if we use this. Then what else? We are now looking for the perimeter of the shaded segment. So perimeter of the shaded segment, I need this BC here. So there are 2 ways I can do that. Okay, I can split this one into 2. When I split it into 2, that means, of course, this one is going to be a half of AB. Okay, even this one is a half of what? AB. So this angle here is going to be theta over 2, and also this one is theta over 2. So relative to this angle here, this is the opposite, and this is the hypotenuse. So we can say, using SOHCAHTOA, because we use SOHCAHTOA when we see a right angled triangle. Okay, then we shall have sine of theta over 2, because that is the opposite and the hypotenuse, then is equal to the opposite, which is a half of AB, then divide by the R. You see that? Now we have sine of theta, which we have gotten as 4 over 3, then divide by 2. Then this one will be equal to 1 over 2R. Okay, because this one will multiply with the R down there, and our R is the 6 here, then of AB. So meaning AB is going to be equal to 12, then sine of course, you have 4 over 3, then times the reciprocal of the denominator. So that one will be a half. So this one will go here 2 times. So it will be, we shall have 2 over 3. Sine of 2 over 3. So I keep that one there. Alternatively, I can find, I can find AB using the cosine rule. Okay, so I know the angle, I know these 2 sides, I can find this side there. So what do we do then? We can say AB using cosine what? Using cosine rule. So we can have AB squared is equal to, so whatever is this side, we have r squared. Our r is 6, not so? So 6 squared, then plus 6 squared minus 2 r times r, like these two sides here, okay? These two. So r times r, that will be 2r squared. So that is 6, and then a 6, then cosine of the angle which is opposite, okay? The angle which is opposite to this side here. So that angle is that theta. So cosine of theta, which theta is 4 out of what? 3. So meaning our, of course, this one is supposed to be squared. Then I will take the square roots on both sides. So I'll have something like that. And this one will simplify to the square root of 6 squared is 36, then plus 36, that is 72. Even here we have 72, then the cosine of 4 over 3. So these two can give us the same answer. Let's check it out. The calculator has to be in radians, okay? Mine is already there. So if we have 12, then sine of 2 out of 3, we get that answer. How about when we get the square root of 72 minus 72, then cosine of 4 out of 3? Do we get the same? It's the same answer, you see? So whichever way. Now let's go to the perimeter of the shaded region. Perimeter of shaded region, as the segment. So this one is going to be equal to the arc length of AB, then plus the straight edge AB. Okay, just look at this one here. We have this and then this. Remember, for perimeter, we sum up the lengths of the sum of the distances around the shape. So arc length AB was given as 8, and then this one we have gotten it as 12 sine 2 over 3, or you can use this one here, right? And then what is our answer to 3 significant figures? So I will just come to this one and I say 8 plus that. You see it is 15.4. How about if I go up and I also use this one here and I say 8, then plus that? Is it also 15.4? Simple as that. That is 15.4 centimeters. This is to 3 significant figures, and that is that. Then part B, find the area of the shaded segment. Now, area of shaded segment, if you check, you will see that the segment, the sector here is bigger than the triangle. So meaning I'll get area of the sector minus area of the triangle. So that will be area of sector minus area of triangle. And this one is going to be a half r squared theta. This one is going to be a half r squared, then sine of theta. Because whenever you have a triangle that is not right angled, you just look at this side if you know it, and this side you know it, and then the angle in between those two sides, it's a matter of getting a half, then times a here, then times the b here, and then sine of the angle in between. So when I look at that triangle there, we have the r and also this one, then the angle in between them, we know it. So let's go. Did they give us the area of the sector? No, they didn't. They just gave us the perimeter of the sector. So we shall have this one as a half, then times the radius. Radius, we got it as 6. So this is 6 squared. And then the theta, we got it as 4 over 3. Then minus, this will be a half. Again, 6 squared. and then sine of theta, which is 4 over 3. So when we put this in the calculator, 6 squared is 36. So 36 then times 4, then we shall divide by 6, because 2 times 3 is 6. That will be 24. Let me write 24, then minus, this will be 36 divided by 2, that is 18, then sine of 4 over 3. So what do we get? The 24 we have here minus 18, then sine of 4 out of 3. So this one will be 6.51. 6.51 centimeters squared. This is to 3 significant figures. That is that. Question 6 is coming from trigonometry, part A. Show that this one here is equal to 1 may be expressed in the quadratic equation in sine, where a, b, and c are constants to be found. Okay, now we are going to have, let me first write the whole of this down here, sine of theta, then plus the cosine of theta, and then we have plus 1 out of the sine of theta minus the cosine of theta, which is equal to 1. So we shall get the common denominator here. It is the product of those two. Okay, then after multiplying these two, then I'll multiply this with that. Okay, and then this one with that. So we shall have sine theta here, then minus cosine of theta. That is when I multiply this with this. Okay, then this one here times the one here, you will have plus sine of theta plus cosine of theta. Then we are dividing by sine theta plus cos theta, then multiplied by sine theta minus cos theta. Then this one is equal to 1. From here we can see cosine going. So that means we shall have 2 sine theta up here. Okay, and then when we cross multiply here, we shall have, this is a difference of 2 squares, because you know that a squared minus b squared is equal to a plus b, and then a minus what? B. So this one is the same. This is our a, this is our b. A and then b. So we just need to square the sine, and then we also square the what? The cosine, just like that. And we also know that this one here, based on what we are having here, we need to express cos squared theta in terms of sine squared theta. And you know the Pythagorean identity here in trigonometry, which says that sine squared theta plus cos squared theta is equal to 1. Therefore, cos squared theta is equal to 1 minus sine squared what? Theta. So we have 2 sine of theta, which is equal to sine squared theta minus 1, then plus sine squared theta, because the negative affects this negative, right? Or whatever is in the brackets. Then this is 2 sine squared theta. So we have 2 sine squared theta. Bring this one this side. It will be minus 2 sine theta. Then there is this minus 1, which is going to be equal to 0. So this is our quadratic equation in sine theta. That means A is 2, B is negative 2, and C is negative 1. So since they said, I remember they said that we have these A, B, and C are constant, so they can be positive or negative. So don't be confused, because here I'm having the minus, and then here you're having a plus. No, B can be plus or minus. Okay. Then part B, hence solve this equation here. Now, this equation here, we actually got this. Okay. So we shall write 2 sine squared theta minus 2 sine theta minus 1. This one is equal to 0. This is a quadratic in what? Sine theta. Quadratic in sine theta. So let's check whether this one can be solved using the what? The calculator. Like, is it factorizable? That's what I mean. So mod, then equation is 5, and then quadratic is 3. So the coefficient of sine squared here is a 2. The coefficient of sine is a -2. And then the constant part is -1. So when we press equals now, that is what we are getting. Okay. Now what we are going to do here, since this one is not factorizable and it is giving us that, you can skip space again and you say this is sine of theta, which is equal to 1 plus root of 3 out of 2. Then the next one is sine of theta, which is equal to 1 minus root of 3 over 2. I believe that is the one. Yes. Now, from here, you have to show the examiner the attempt to solve this. Now, when it comes to factorization, we could say multiply this one here, then bring this one here. Now, here we are having SADs. So, what you can do here, you show the examiner that you substituted in the quadratic what? Formula. So, you say sine of theta is equal to minus b, okay? Because the b is a -2, so I'm putting minus, then the b is this, then plus or minus to the square root, okay, minus b plus or minus square root of b squared minus 4ac, then out of 2a. Okay, you have done this one here. Now the examiner will see the attempt to solve the quadratic equation, then you can write your 2 here. You see that? Okay, now from here, let's check what we are having here, whether it is greater than 1, because we know that sine of an angle doesn't exceed 1, okay? And it doesn't go beyond the -1, so that is it. So let's see which one falls within. 1 plus root of 3, then divide by 2. This one is giving us 1.36. That means when you get the arc sine of this, it is going to give you math error. Okay, let me just show you. If I say the arc sine of this one here, you see math error. So sine doesn't go beyond the 1. So meaning this one, we say it is undefined and we leave it. Okay, then we shall come to this one here. Is it a positive or a negative? So we have here, it has to be a minus, and then that one is a negative. So because it is a negative, then when we come to our 4 quadrants here, we are supposed to pick the angles from where sine is negative. Here, all are positive. It is only sine positive here. It is only tan positive here. It is only cosine positive here. So we have 0 degrees, then 90 degrees. This is 180 degrees. This is 270 degrees. Then by the time we come back here, that is a complete oscillation. So that is 360 degrees. Then when we go anti-clockwise, the angles are positive. When we go clockwise, the angles are negative. Now we are supposed to pick angles from the quadrants where sine is what? Negative. And that is the 3rd quadrant and the 4th what? Quadrant. So suppose I put an x here, then I also project it here. Opposite angles are equal. That means this one will be 180, then plus the x, and then put it here, and also there. So that means this one will be 360 minus the x. And this will be, of course, 180 minus x. So we are moving like this up to there. Okay? So you get from here up to here is 180, then minus this. That is how you get the angles in the 2nd quadrant. Then in the 3rd quadrant, 180, then plus that x. In the 4th quadrant, from here up to here, it will be the whole of this 360, then minus what is here. So we look at the deviation from the horizontal axis, okay? Don't use these angles here, 90 and 270. Now, our theta here is going to be equal to the arc sine of 1 minus root of 3 out of what? 2. Now, ignore the negative. You first get the acute angle, okay? When we ignore the negative and then we get the what? The acute angle. I want to first shift this one here a bit. and put it somewhere here, like that. Put it here. So when we ignore the negative, we shall get the acute angle, right? So what I will do, I'll come back to this one and then I put a negative there, okay? Then it becomes a positive. You see that? Then I will say arc sine of the whole of that. But here the calculator is in radians, yet we are given the domain in degrees. So you have to first change this one to degrees. So this will be 3. And then when I press equals again, so that is 21.5. So that 21.5, this is the acute angle, okay? But I'm supposed to go to quadrants where sine is negative. So where sine is negative, it is here in the third quadrant. So I will say this is the 180 here, then plus that x we have gotten, which is 21.5. And then the other one, where it is negative, is here, that is 360 minus that 21.15. Okay, so then what do we get as our answer here? So our theta is going to be equal to, this is 201. This is 201.5. And then this one here is going to be what? 360 minus 21.5. That one will give us 338.5. 338.5 degrees. These angles at 1 decimal place, and that becomes our answer.